Hello everybody, this is Dr. Christopher White, and in this video we are going to be looking at the absolute age dating assignment. So the absolute age dating assignment consists of 8 pages. The first 2 pages, we can see here, is a discussion of radioactive decay and changes in parent and daughter isotope between half-lives. So please read it. Okay, it's interesting stuff. Don't just ignore it. Take a minute. It'll help you with the rest of the lab. Now, I'm going to skip these pages for just a second. We're going to come back to them. And we're going to end up here on page 6, page 7, and page 8. Now, I personally tend to find the questions that are asked on page 7 and page 8 are needlessly, shall we say, fuzzy. There's a lot of room to make mistakes on them. So I tend not to use the questions on pages 7 and 8 just purely because there's more of a chance of you losing marks than gaining marks on those questions. So what we're going to do is we are going to exclusively focus on the questions on page 3, page 4, and page 5. And as far as you guys are concerned, page 6, 7, and 8 do not exist. Alright, so now you've got that clear, let's start thinking about what we've got to do. Well, the first exercise is essentially understanding half-lives and isotopic decay. So what we're going to try and do on this question is we are going to try and essentially work out what's happening to the number of parent and daughter isotopes every time we go from one half-life to another. So you can see the half-lives listed across the top here: 0, 1, 2, 3, 4, 5, and 6. All right. And as you know, we're going to calculate changes in these numbers as we go from one half-life to the next. So it's a relatively simple job. Now, in order to answer this particular question, we have a few options. The first thing you will have noticed is that this is a PDF document. Okay, so it makes it a little bit difficult to write on it. Now, it's not one of those nice PDF documents where essentially it already has text boxes pre-inserted. You just have to type in the data using your keyboard. Nope, I'm afraid not. So there's a few possible options to actually do this document. So the first method is to go to Word. Actually, sorry, I'm just going to make this a little bit smaller. Move it to one side. There we go. The first option is to go to Word and insert a table. Okay, and if you don't know where it is, you would go to Insert, Table, and then you would make the table the correct size. In this case, it's 8 columns wide and 7 rows deep. Okay, so now you can see I've already gone and produced a table right here. Now I've simplified the text here. You would write all the text we see here. Okay, I was just doing this quickly, so hence the fact I've simplified it. And then obviously we can fill in the boxes one at a time as you go along. Another option you have is that we can take ourselves a screen grab. So I'm sure you're used to doing this by now. So print screen, okay, on your keyboard. Then we're going to go to a program that's going to allow us to edit the image. So I personally just like to use PowerPoint. I just find it very simple. All right, we're going to paste the image. Now, oh, there's me again, aren't I? And as you can see, now I have 2 screens running at the moment, so hence the fact I have a very long image there. So I'm going to crop this to get rid of all the junk that I don't want. So I'm going to get rid of all of this stuff. Okay, so that's good. So that's all the rubbish I don't want gotten rid of. So now I'll just put that on the slide. I'll just expand it to make it a little larger. There we go. Good. And so there's my table. Now, then what I can do is I can then use text boxes and put a text box in here, and then I can type in my answer. So, put this one here. By the way, I just wish to point out these are random numbers. They're not numbers that have any... Nope, that was getting a bit generous there, aren't I? That have any reference to the actual lab itself. So just going to make that one clear now. So these numbers mean nothing. And then I would insert and fill in all the cells using the text boxes. And so then what I would do, once I'd fill the entire table out, of course, then I would select everything. I would of course go to Group, and I group it all together so it's one solid document, so when I move this stuff around things don't get lost. Okay, and then what I would do is I would copy the document, and then I would go across to my Word document and I would paste it. Okay, and so this would be one of the other ways of doing it. So obviously now I have my table, all the answers nice and neatly filled out, done. Okay, so that's option number 2. Option number 3 depends on what program you're using. Now I'm using Microsoft Edge to look at the document here. Now one of the things that Microsoft Edge allows me to do is it allows me to add notes. Okay, so if I want to, I can hit add notes, and you see it's going to give me a pen up here. Now I wish to be clear, I'm going to do this using a mouse, so it's not going to be very nice looking. Now you should only really do this if you have a touch screen and you have some kind of stylus that's going to allow you to write things neatly so they're legible. And so maybe the answer is 12. The answer for this one is 4. The answer to this one is 6. The answer to this one is 100. Okay, so you can see I can fill out the cells, and then you can save the document with the notes, and obviously you can print out the document with the notes. Now if you don't like what you're doing, of course there's the erase tool up here, and that will allow you to just get rid of all of this stuff. You just click on it and it erases it. Nope, of course now it's not going to. Good work. There we go. You've got to get it just right. That's one of these slightly annoying things. You never can quite work out exactly where the spot is. There we go. To actually make it erase it there. Done. So you can also fill out the tool. You can also fill out the table using the notes tool if you are using Microsoft Edge. Please remember though, if you are going to do that, that's okay when you're doing stuff like this. And even the graphs, you can use it for doing that. But when you are answering these questions here, please bear in mind you might need to write things a little bit more neatly. So, just think about, exactly how you're going to do it. Okay? All right, so anyway, let's look at our table. Now, just to keep life simple, I am going to go to Word. All right, so I'm going to use the table I did in Word. You don't have to do this. This is just the way I'm going to do it. Okay, oh, that's not what I want. I want this one. No, go away. Right. So here we go. So this is my table. So what we're going to do is we need to calculate the changes in these numbers as we go from one half-life to the next. Okay, so if you remember, every time we go from one half-life to another, the amount of parent isotopes will halve. That's why it's called a half-life. So as we go from 128 to half-life 1, we will halve the number of parent isotopes. So that means half-life 1, the number of parent isotopes will be, going to give you a second to do that calculation, and of course the answer is going to be 64. All right. Now, what are we going to do here? So when we do this calculation, the situation is going to be this. So remember, this is the percentage of the parent isotopes. So in order to do this calculation, we're going to take the number of parent isotopes we have. We are then going to divide that number by the starting number of parent isotopes, 128. Okay? We're always going to divide by 128. So whatever the number is here, we're going to divide it by 128. So we're going to get that answer, and then we're going to multiply by 100. So this would be 64 divided by 128, which would give us 0.5. And then we would multiply that number by 100, which would give us, over to you, 50 would be the number. So 50%. Done. Okay. So now we have to do the number of daughter isotopes. Well, what's happened here is we have turned some of the parent isotopes into daughter isotopes. Now, remember, when we do that, we haven't actually lost any atoms, have we? All we've done is we've taken one atom and we've turned it into another atom. So just bear that in mind. So what we're going to do to calculate the number of daughter isotopes is we're going to take the number up here. We're going to take 128 and we're going to subtract whatever the number is up here. Okay, so in this case it's going to be 128 minus 64 is obviously going to give us 64. All right. Now, on half-life 2, it would simply be 128 minus whatever the number is here will give you the number of daughter isotopes. For half-life 3, it's 128 minus whatever the number is here will give you the number of daughter isotopes. Okay? All right, so what about the sum? Well, the sum is obviously going to be 64 plus 64, so that's going to give us 128. What about the daughter to parent ratio? Well, that's simply going to be 64, the number of daughter isotopes, divided by 64, the number of parent isotopes. So that's going to give us 1. And then we need to work out how much time has passed. Well, we're very lucky in that on the page, in the actual assignment itself, it tells us what the half-life is. So the half-life we're using is 704 million years. Okay? And so the amount of time between half-life 0 and half-life 1 is... Oh, forgot the 7 there. That didn't go very well, did it? Let's try that again. Would be 704 million years. Okay, so that was half-life number 1. So let's just discuss what you would do for half-life 2. Now, I'm not going to write it. I expect you guys to be able to follow along with me and to be able to do this yourselves. So for half-life 2, the amount of parent isotopes is going to be half of whatever the previous number was. Okay? So for half-life 2, it's going to be the amount of parent isotopes at half-life 1 divided by 2. Okay? For half-life 6, the amount of parent isotopes would be the number of parent isotopes at half-life 5 divided by 2. Alright, so as we go from one to the other, we're simply dividing the previous number by 2. Very simple. Now, the percentage parent isotope left, okay, well, that one, of course, is going to be, the number of parent isotopes up here divided by the starting number of parent isotopes, so 128. You are always going to divide by 128. Okay, so for half-life 2, it's this number divided by 128. You get that answer, then you multiply by 100. For half-life 6, it's going to be this number divided by 128. So you get that answer, then you're going to multiply by 100, and that's going to give you your percentage. In terms of the number of daughter isotopes, it's simply going to be 128 minus whatever the number is up here. So for half-life 2, it's going to be 128 minus this number here will give you the number of daughter isotopes. The sum, so the total number of isotopes, will simply be the number of parent isotopes plus the number of daughter isotopes. Daughter over parent ratio, well, that one's really simple. That's simply going to be this number here, the number of daughter isotopes, divided by the number of parent isotopes. That one's a super simple one. And it's going to be a round number. So don't start giving me fractions, just write 1, 5, 9, whatever number it spits out, okay? Don't overcomplicate things, please. And then we have time. So as we go from one half-life to another, all that's happening is it's taking, essentially, another 704 million years. So it took 704 million years to go from half-life 0 to half-life 1. So it's going to take another 704 million years to go from half-life 1 to half-life 2. another 704 million years to go from half-life 2 to half-life 3, and so on. And so this means every time you go from one half-life to another, you are simply adding 704 million years. So for half-life 2, it would be the previous number, so in this case 704, plus another 704 million years. Okay, so all you're doing is you're taking the previous number and you are adding 704 million years. Okay, you're not doing anything interesting, you're not subtracting, not dividing, not multiplying, you are simply adding 704 million years to whatever the previous value was. Done. So hopefully you should be able to fill out this table relatively easily. And this table is showing you essentially what's happening to the number of parent isotopes as you go from one half-life to another, and what's happening to the amount of daughter isotopes as you go from one half-life to another. Okay. So what are we going to do next? Well, next I'm going to open up the document again. All right, so here we go. So that was the table on page 3. So now, as you can see, we have these pieces of graph paper on pages 4 and 5. So what we can see is, in this case, it's the number of parent isotopes left, okay, versus time in billions of years. So what we're going to do is I'm going to go, just to make my life simple, I'm just going to use the draw tool. Now, once again, you could put this into Power. You could do a print screen, put it into PowerPoint, draw the marks yourself on PowerPoint, and then paste that image into Word. Okay, that's another option. All right. Now, for simplicity's sake, I'm just going to quickly draw the marks on here. Okay, so what we're going to do, we need the number of parent isotopes left. So initially, we're going to start off with half-life 0. So in half-life 0, the time is 0. And the number of parent isotopes is 128. So time is 0. And we're going to come up here. All right. Now, obviously, as we're going up, so it's going to be 5, 10, 15, 20. Oh, let's try that one again, shall we? 5, 10, 15, 20, 25. So each one of these blocks is worth 5. So in our case, there's 125, so 130 is going to be here, so 128 is going to be kind of there. Okay, not perfect, but pretty much on the mark. Okay, so then we have half-life 1. So half-life 1 is 700 million years, otherwise known as 0.7 billion years. So we're going to come along here, and so as you can see, 5, 6, 7, 8, 9, 10. So each one of these is worth 0.1 billion years. So alright, so that's 5, there's 6, and there's 7. And the number of parent isotopes we have now is 64. Okay, so off we go. Where are we? There's 7. I'm going to come up here, and we're going to find 64. So there's 50, 55, 60, 65. So, make our life simple. Okay, so we're going to put our mark. Sorry, I completely lost my position. I do apologize. 50, 55, 60, 65. So we're going to put our mark right there. Okay. And then you're going to continue your way across. So for each time unit, for each half-life, you're going to work out the time in billions of years. And then you're going to simply add the number of parent isotopes onto the graph. Okay, then you're going to have a set of lines, and then in a perfect world you will simply draw and link the lines up and and draw whatever happens to them. Okay, so that's what you're doing on the parent isotope versus time graph. Just need to try and get rid of this stuff now. Where's the magic point to get rid of it? It's got to be around here somewhere. There we go. So we need to we're going to click around randomly until we get rid of these points. There we go. Okay. So now what about the daughter isotopes? Well, in this case, we are worried about the number in this row. In this row. Okay. Well, initially, we're obviously going to start off at time 0 with 0 daughter isotopes. So we're starting off right down here. Oh, no, I'm on a race right now, aren't I? Silly me. There we go. We're starting off down here at 0. Okay. So once again, 704 million years is 0.7 billion years, and now we have 64. So here we go again, there's 0.7, going to come up here, there's 50, 55, 60, 65, so we're going to make our point right there. Okay, then you're going to make all the rest of the points, so every time you do a half-life, you're going to find out what the age is, you're going to get the number of daughter isotopes, and you're going to put the value onto this graph here. And then once again, once you have your points, if you can, in a different color is always a good idea. So let's just say yellow. You're going to link up your points, okay, just so I can see where the line is going. You know, does it go down here? Does it go across here? Maybe it does this. Maybe it does some of that, okay? So just link your points together. If you can please leave it so I can see your points, that's really helpful to me when it comes to marking, okay? Now, obviously I've used the tool on Microsoft Edge to do this, so you know I've kept things relatively simple. But once again, if you want to do this probably more cleanly in another program, you can just simply print screen, take that image, dump it into PowerPoint, crop the image to the correct size, and then draw the points in the correct position on PowerPoint. Okay, and then obviously you take that image, and then you just simply copy and paste it into a Word document. All right. So then down here we have the ratio of daughter to parent isotopes over time. So this is simply going to be this column, sorry, this row right here, and this row right here. So that's where you're going to find that data. So obviously, as we know, at time 0, the parent to daughter ratio was 0. So okay, I'm going to go back. I'm going to start off with my blue point. So here we go, 0, 0, right there. And then after 704 million years, 0.7 billion years, the number was 1. Okay, now look, the scale has changed slightly. Each one of these squares is worth 1. So here we go, 0.7 billion years, 1. Okay, and then obviously you're going to put in the rest of the points as you work them out. Okay, so remember, daughter to parent ratio is simply this number divided by this number. Very simple calculation. Okay, now I'm sure you can work out relatively easily that this number is going to start increasing as you work your way along. So once again, I'm just going to make it a different color just so I can, you know, not lose the points. So I would, you know, link the points together, then I'd link that point together to there, that point together to there, this point together to there, and so on. Okay, so obviously now please bear in mind I'm just drawing these points randomly. This has nothing to do with the actual values you're going to get. Okay, so you'd have something that looks a bit like that. Okay, if you're using something like Microsoft Edge. Okay, as I said, if you want to get this looking a bit smoother, you can use a program like PowerPoint. Okay, so let's just erase all this stuff once again. Got to find where the correct point is. Got to be around here somewhere. That was the easy stuff. Come on, go away, please. I'll eventually find it. So Microsoft Edge is a little bit clunky. Okay, so if you're going to do it in PowerPoint, on the other hand, we would, well, once again, go for the good old-fashioned print screen option. So where's print screen on my keyboard? There it is. So print screen. We would then go to PowerPoint. Okay, once again, we would zoom out. We would paste the screen grab that we just took. Once again, we would crop the image to the correct size. So we'd get rid of all of this junk here, because remember, we're just after the table. Or sorry, the graph paper, should I say. That's what we want, so all the rest is completely useless to us. I'm just going to zoom in for a second, so we can get rid of that question more efficiently. There we go. Get this here, expand it a little bit so it's a bit larger. There we go, there's our graph. Okay, so if you remember, we're starting off here at, now I'm just going to make this red just so it's a little bit more visible. There we go, make the outline red as well. Sorry, my camera's right in the way of where I want to be. Okay, there we go, so this is going to be our point. So obviously we start off here at 0, 0. Now hold down the Alt key so you can move things accurately. There we go. Then we're going to, now I'm just, to make my life simple, I'm just going to copy and paste. I'm going to cheat. And if you remember, the next point was a daughter to parent ratio of 1 after 0.7 billion years. So I'm going to move this to the correct location. So there's 0.5, 0.6, 0.7, and 1 is going to be right there. Okay. Now for argument's sake, I'm just going to put some more points on. That's actually too many points. But I'm just going to say it does this, it does that. Now once again, remember the points that I am drawing here are not representative of what you will get from the table. This is just me making stuff up. Okay? And so in order to join this stuff together, I'm going to simply do something, well, you could do something like freeform and just go that one to 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 that one. Of course, double click when you're done, and that's your line. Done. Or you could use something like the curve tool, and you could go right from one to the other, to the other, to this, to that, to that, to that. And it's going to, remember, double click again to finish, and it's going to give you a little bit of a smoother line there. All right. So once we have this, of course, what do? We select everything. We go to group. I should have said, by the way, you select everything, and then you right click on the image. That's how you get this menu. You go to group. There we go. We're going to group all this together. That way we can't lose it when we move it around, so all the points stay in one place. Okay. And then once again, just like before, we are going to copy the image. We're going to come to our Word document. Here it is. Going to go to the next page. That didn't go well, but it doesn't matter anyway. And then we would paste our image there. Okay. So as you can see, we have a few options to draw these graphs. You can either do it in the program that you're looking at the document in. As I said, I'm using Microsoft Edge. Or you can copy. Essentially, you can take a screen grab of the graph, put it into PowerPoint, fill out the points there, and then paste that resulting image into a Word document. All right. The options are, it's up to you as to which one you would prefer to do. Now, the next step is going to be getting rid of this, getting rid of that, and getting rid of that. Okay. Obviously, the next step is to answer these questions right here. Okay. So these questions are all relatively straightforward. I think on the whole, you should be able to answer them without too much fuss. Okay. So just try and be consistent. So for instance, it says uranium-235, decays to lead-207. What is the half-life of uranium-235? Well, I'm not going to tell you. All I'm going to tell you is that you might want to, look at the table on page 3, and that might give you a hint. You could also maybe look at the table down there on page 6. You have options. So you see, the answer for this stuff is actually, the answer for these questions on the whole, they're relatively straightforward. So how much time has passed after 4 half-lives of uranium-235? Well, it just so happens that you have this information on this table right here, don't you? So, you don't really have to work very hard for it. What is the ratio of daughter to parent after 4 half-lives? That's going to be for uranium-235. Well, once again, you happen to have the answer on this table on page 3, don't you? It's all right there. So you don't have to work particularly hard to get the answers for most of these questions. These last 4 are a little bit more complicated because there is a little bit of math involved, but I think you should all be able to do it relatively easily. The one thing I would ask is please, please, please show you're working. All right, so you're going to get a mark for the answer, but you're also going to get marks for showing your math. All right, please bear that in mind. So if you don't give me any of your working, you aren't going to get as many marks as you could. Okay, and that's really it for the Absolute Age Dating Lab. It's relatively straightforward. So at the end of it, you're going to have either one of 2 different types of document. Either you're going to have a document that you've filled out using a program like Microsoft Edge, and you've written the answers. Okay, once again, please when it comes to this part, when you are writing the answers, please try and be as tidy as possible so I can see what you're doing. Okay. Or the other option is that you've taken repeated screen grabs of each page, you've put them into a program like PowerPoint, okay, and then you've copied and pasted the resulting image, and then you've dumped it into Word. Okay, so either you're going to be submitting a PDF file which you've drawn on using a program like Microsoft Edge, or you're going to be submitting a Word document, essentially where you've screen grabbed the images, filled them out in PowerPoint, and then dumped the resulting image into a Word document. Those are pretty much your choices. Obviously, please make sure. Sorry, I've got to find the right tab. There we go. Please make sure that you keep any information like the exercise 1, so I know what exercise you're giving me an answer for. That's especially important for these questions here. Make sure you keep the question number. Okay, so if you're doing a Word document and you're answering question 1, you need to tell me that you're doing question 1. Okay, if you don't tell me you're doing question 1, I can't give you the marks because I don't know what question you are answering. Okay, please bear that in mind. I would know what question you are answering, but if you don't give me the question number, I can't give you the mark. Okay, doesn't matter. All right, so please don't forget to do that. And that's about it, really. It's a relatively straightforward process. Once again, if you have questions, you can email me, or you can come to the office hours on the allotted day and time. Okay, everyone. Okay, have fun with this lab. It's nice and short. I think you should all be able to do it very, very well. So take care.